Alright, time for the solutions for the compound inequalities worksheet, the one that says secondary math 1 at the top there. On this first one, on all of these really, there's multiple inequalities. You solve them both separately, and then graph them both on that number line, and you'll be good to go. On this first one, on this left side, I'm going to do the left one first. I'm going to subtract 9 from both sides to get 9n less than or equal to negative 72. And if you divide by 9 on both sides, you'll get n less than or equal to negative 8. And on the right side, if you add 1 to both sides, then you'll have 9n greater than or equal to negative 63. If you then finish that out by dividing both sides by 9, you'll have n greater than or equal to negative 7. So now we have two different inequalities. Here we have the OR statement, so we're fine with either of those, any solution that satisfies either of those. Let's graph them both. Let's graph this left one, put a circle there at negative 8, and since it says less than, n less than negative 8, we need to shade left on that guy. So shading left from that negative 8, and since it says less than or equal to, we're going to fill in that circle. And then on this, the right one, we're going to go to negative 7. It's also filled in because it says greater than or equal to. And since it says greater than, we're going to shade right. N is greater than negative 7. So that's it. So those are going to be our solutions. Any number that's less than negative 8 or greater than negative 7. That brings us to 2. On 2, this is an AND statement. It's the left inequality and the right inequality. They share this middle part, so that part would be the same on both inequalities. And so what I can do is actually solve all the inequalities at once by doing one thing to the center and to the outside equations. Negative 52 plus 10 is negative 42, less than or equal to 7p. And then 53 plus 10 is 63. If you divide by 7 on all sides, you'll get p less than 9 and negative 6, less than or equal to p. So now here's my inequality. And really to graph that, you just go to negative 6, put a circle there, and I'm going to fill it in because it says less than or equal to. And p is bigger than that negative 6, so we're going to be shading to the right. We'll also put a circle at 9, which is right here. We're not going to fill it in because it says just less than, but not equal to. And p is between those two numbers, so we're going to fill in this middle part, and that's where the solution space is. If you move on to 3, this one, again, has two different inequalities that we can solve and then graph their answers. For this first inequality, I need to get that n all by itself. So I'm going to add 4 to both sides to get negative 3n greater than or equal to 30. I'm going to divide by negative 3. And remember, whenever you divide by a negative, you need to switch the direction of your inequality. And so now we have n less than or equal to negative 10. I'm going to graph that right now, fill it in, because it says less than or equal to. And I'm going to shade left. I'll put an arrow there. Okay, so all numbers including negative 10 and then less than. On this right inequality, I'm going to subtract 3 from both sides to get negative 7n less than or equal to 28. And I'm going to then finish out by dividing both sides by negative 7. Anytime you divide by a negative, you need to switch the direction of your inequality. So I just flip that there, and 28 divided by negative 7 is negative 4. So now I'm going to graph that one. So put a circle at negative 4. I'm going to fill it in because it says greater than or equal to. And since it says greater than or equal to, I'm going to shade to the right. Put an arrow there, and there's my solution space, the graph. Moving on to the next one. This one, since both the ends are just constants, and we have an and statement here with this middle part that will be part of both the inequalities, I can solve them all at the same time by subtracting 1 from all portions to get negative 81 less than or equal to negative 9a less than or equal to 27. And I can then divide all sides by negative 9. And you need to remember, when you divide by a negative, you have to change the direction of your inequalities. Negative 81 divided by negative 9 is 9. Switch the direction on that one. 27 divided by negative 9 is negative 3. So now here's my answer part. I'm going to put a circle at both of those. I'm going to fill them both in because they have the or equal to part of each of those. So negative 3 and at 9, fill them in. And I need to shade between them because A is between negative 3 and positive 9. So that's our solution space, from negative 3 to positive 9. And that brings us to 5. Again, we have just constants on the outside, and so we can solve by doing the same action to all the pieces. There. Negative 76 minus 4 is negative 80, less than or equal to 10n, less than 20. I can now divide everything by 10, and I'll get n less than 2, and negative 8 less than or equal to n. So there's my solution there. And I'm going to graph it now by putting a circle at negative 8 and filling in the circle because it says less than or equal to. And I'm going to put a circle at positive 2. But I'm not going to fill it in because it doesn't say or equal to. But n is between negative 8 and positive 2, so I'm going to come here and fill in the space between. All those numbers are bigger than negative 8 and less than 2. And that brings us to 6. Again, we have this situation, constants on the side, and then our expression with the variable in the middle. So we can add 4 to the inside and the outsides to solve both the inequalities at once. Negative 6 plus 4 is negative 2, less than or equal to negative 2x, less than or equal to 20. You can now divide by negative 2 everywhere. And remember, when you divide by a negative, you need to change the direction of your inequalities. X will be in the middle, right side will be negative 10, and the left side is going to be 1. So here's my answer. I'm going to put a circle at both 1 and negative 10 and fill them in because it says or equal to on both our inequalities. And X lies between negative 10 and positive 1. So I'm going to fill in the middle part of these two circles. And there we go, there's a graph for that. And moving on to 7. I'm going to split this right here in the middle. We have two different inequalities, or statement in between. Solve them separately, and then you can graph your inequalities. So on this one, I'm going to do minus 3r on both sides to get r minus 5 greater than or equal to 4. I'm now going to add 5 to both sides to get r greater than or equal to 5. So if I go to 5 and put my circle there, fill it in because it says greater than or equal to, I'm going to be shading that direction. Let me get the other one done. So on this part, I'm going to subtract 4r from both sides to get negative 9 plus r less than or equal to negative 1. I'm going to add 9 to both sides, and that'll finish it up with r being less than or equal to 8. And so, here, if I finish out the graph of the left one, you notice it's just going to go right forever, that way. And then if I graph my right one, I need a circle at 8, fill it in because it's less than or equal to, and I'm going to shade left. Notice this one says or, and so if we have any number that satisfies either inequality, it's part of the solution set. Well, every number satisfies one of those. Every number is bigger than 5 or less than 8. And so, really, this would be all real numbers as our solution set. I just want to mention that. And we can get talking about later what that actually means. And so we'll stop there.